Frequent question is about symmetry tests. Symmetry tests are conducted by substituting in a certain manner to see if the expression we get after substitution is equivalent to the original expression. To illustrate, symmetry test for symmetry with respect to the y-axis involves substituting negative x for x. So let's take an expression like y equals 5 plus x squared. Now we do the substitution. We substitute negative x for x. That means that instead of x, we're going to have a negative x here. So substituting, we get y equals 5 plus negative x quantity squared. Now the question is this expression equivalent to the original? And the answer is going to be yes. We see that by saying that y equals 5 plus negative x squared is equivalent to, and I'm going to write a double arrow here. It's like an equal sign with an arrow pointing this way and arrow pointing this way. This is equivalent to y equals 5 plus x squared, since the square of negative x is x squared. That's the same as the original. So we do have symmetry with respect to, that's what the WRT stands for, with respect to the y-axis. Now if we plot y equals 5 plus x squared, I'll do that here, you can verify that that graph goes through the point 5, 0, and the points 1, 6, and negative 1, 6, and it's a parabola. Okay, and that is symmetric with respect to the y-axis. If I have a value x here and project up to the point on the graph, so if this is my value of x, and I have then negative x over here, if I project up to the graph from this point negative x, well, I didn't draw the graph too well. Negative x has to be just a little further from the axis than that. That's probably too far, but you get the idea. And we go up to the point on the graph. We get the same y value. If we do 5 plus x squared and 5 plus negative x squared, we get the same thing, meaning that this point is a reflection of this one and vice versa. Again, the graph wasn't drawn completely accurately, but if you had a completely accurate graph, you'd see that. Of course, your text shows you that. Another type of symmetry we often want to test for is symmetry with respect to the origin. So to test symmetry with respect to the origin, we replace y by negative y, we replace x by negative x. Here's an example. Okay, so substitute. You should do the substitution. Pause, do the substitution. See if you get what I'm about to get. Now, hopefully you paused. We get negative y cubed, replacing this y with negative y. 1 over x cubed will become 1 over negative x quantity cubed. Minus x will become minus negative x. Now, is this equivalent to the original? So you should pause and see if you can, by using valid steps, rearrange this equation so that it becomes the same as this one. Well, you should have done that, but let's see now. If we cube negative y, we get negative y cubed. If we cube negative x, we get negative x cubed. If we subtract negative x, we get plus x. Now, is this equivalent to this? Might not look it, but let's see. The difference between the negative y cubed here and the y cubed here is the negative sign. Let's go ahead and multiply everything in the equation by a negative sign. That'll make this negative y cubed into a y cubed, and that way, if multiplying this side by the negative sign brings it into agreement with this side, we know we have the symmetry with respect to the origin. So we do minus 1 times negative y cubed equals minus 1 times 1 over negative x cubed plus minus 1 multiplied by x. Minus 1 times negative y cubed is y cubed. Minus 1 times 1 is negative 1. Negative 1 over negative x cubed, that's a negative over negative. That's going to give us 1 over x cubed. And plus a negative 1x cubed, that's going to be plus a negative x. Well, that's the same as minus x. And if we look at this and this, we find that they are the same. Conclusion, y cubed equals 1 over x cubed minus x is symmetric with respect to the origin. As another example, consider x cubed plus y squared plus 4x equals 9, another equation. We do the substitution. Again, y replaced by negative y, x by negative x. You should write that down before you watch me do it. Okay, so we have negative x cubed plus negative y squared plus 4 times negative x equals 9. Is this equivalent? Well, we get when we expand these terms, negative x cubed plus y squared minus 4x equals 9. Okay, this agrees with the 4 and the 9. So the y squared and the y squared and the 9, the y squared and the 9 are the same, but the x cubed and the negative 4x have opposite signs. So this is not equivalent. This is not symmetric with respect to the origin. Now there's another test that I'm not going to do here. This should be enough to give you the idea. But there's also the test for symmetry with respect to the x-axis. Is the graph above the x-axis reflected by the graph below the x-axis? In the sense that the parabola was reflected from the right to the left-hand side of the y-axis. Do you have that kind of reflection with respect to the x-axis? And you can read about and practice that test. It's done in a very similar manner. Now, if you do have symmetry with respect to the origin, that means that any point you have on the graph for in one quadrant is going to be matched by a point an equal distance from the origin along a straight line through the origin on the other side of the origin. So if we have points like so, then the reflections would be these, and the graph, if the graph, for example, has this shape, the reflections will give you this shape, reflection through the origin. Now that's not what the graph of this function looks like. That's a little more complicated, so I'm not going to actually graph it. But from the examples in the textbook and other examples you can find, you can go to the internet, look up symmetry tests, and see many, many examples. The tests are easy enough to conduct. The substitution is easy. Sometimes you got to do a little algebra to test whether what you get is equivalent to the original expression. But the process is always pretty much the same, except for the algebra of checking out the equivalence. As another example, try y equals 5 plus x squared. You should pause right now and do this one yourself. Okay, just follow the same procedure we did here. Now, hopefully you've paused and done it so that you'll understand more completely what I'm about to do. Well, we're going to substitute. Substitute what? Negative x for x. So we get y equals 5 plus negative x plus negative x quantity squared. Is this equivalent? Well, y equals 5 plus negative x squared is equivalent to y equals 5 minus x plus x squared. Does this match up with the original? I can say it matches the original, except for the negative x. So the negative x here is different than what we have up here where it's a positive x. Everything else is the same. So there's no way this is equivalent to this. So, not equivalent. So, it's not symmetric.